Hi, my name is Red Thorn and I'm currently a fourth year civil engineering student at the Central Queensland University. Today I will be presenting an overview of my engineering thesis, FRP Strengthening of Concrete Beams. Many present structures today require rehabilitation that can be for a number of reasons: damage to the structure, extension of the design lifetime, overloading in exceedance of the design load, plan errors, and inappropriate choice or poor quality of materials are all possible reasons for rehabilitation. Unlike the steel reinforcing, which was formed in the concrete members during construction, the reinforcement used for rehabilitation must be externally fitted. This is one of the reasons as to why fiber reinforced polymer, referred to as FRP, has become a potential reinforcing material, as it has high strength, non-corrosive, is light in weight, and is convenient to work with as it can be cut to length and formed into complicated shapes on site. So after completing research into past experimental investigations, I found that there are a number of issues related to the potential failure modes associated with FRP retrofitted beams in flexure. These include FRP rupture, concrete cover separation, intermediate flexure crack and flex shear crack induced interfacial debonding, plate end interfacial debonding, and concrete compression failure. The aim of this experimental investigation will be to test the effectiveness of chemically bonded FRP strips with and without mechanical anchors as external reinforcing for an under-reinforced concrete flexure beam. In the practical testing of this experimental investigation, there will be three different test specimens. The first is an under-reinforced concrete beam which has no additional external reinforcing and is therefore the control specimen. The second is the same under-reinforced beam that has been retrofitted with an FRP strip chemically bonded across the outermost tensile fiber of the concrete. The FRP strip is situated across the midspan, which is the section that is subjected to the greatest bending moment and flexure. As previously stated in the FRP issues, concrete cover separation and interfacial debonding is a common failure mode of FRP reinforced beams. This is why the third test beam incorporates mechanical anchors between the FRP strip and the concrete beam to try and reduce the FRP specific failure modes. By doing this, I aim to determine the effects of fitted FRP strips to the loading capacity of an under-reinforced beam and how it influences the failure mode of the beam. By implementing mechanical anchors for the third test beam, I aim to determine whether these help prevent debonding failure modes and therefore increase the ductility of the under-reinforced beam with external FRP strip reinforcing. Now that I have established the aim, scope, and deliverables for my thesis project, I now have to develop my proposed project methodology, complete the theoretical calculations using the compatibility and equilibrium equations for the cross-sections, complete risk assessment, and then practical implementation of the experimental phase. Thank you for listening to my presentation.